Hello students. So today we'll be solving multiple choice questions from the chapter Arithmetic Progression released by the CBSE.online. They have released a set of 31 very challenging set of questions, and this will be very helpful for the Icse students who have arithmetic progression for the first term examination. So let's begin with the first one. You can see the questions on the screen. The first question states that if the sum of the series 2 plus 5 plus 8 plus 11 and so on is 60100, we need to find the number of terms. Now let me list the formula here. Sn is equal to n by 2 into 2a plus n minus 1 into d. So therefore, we have Sn equals 60100, a equals to the first term, d is 5 minus 2, which is 3. So we have the expression Sn is 60,100 equals n by 2 into 2a, which is 4 plus n minus 1 into 3. So let me simplify this. So here I get n into 3n minus 3, and I take 2 to the other side, so I get 120200. Now this is 3n plus 1, so I get n into 3n plus 1, which is equal to 120200, or 3n square plus n minus 120200 equals 0. So this is a quadratic equation, and I need to find the roots of the quadratic equation. So if the roots are alpha and beta, then alpha into beta is 3 into minus 120200, which is nothing but minus 360,600, and alpha plus beta equals coefficient of n, which is 1. Now observe this value, 3,60,600. Now if I remove the 600, I have 3,60,000. Now 36 is a perfect square, square root is 6, and 1000 is a perfect square, right? So square root is 100. So 6 into 100 is 600. So this is nothing but 600 into 600. And then I have plus 600. So therefore this value is nothing but 600 into 601. Now how do I get the roots? So I have plus 601 into minus 600 will give me minus 3,60,600. When I add these two, I get plus 1. So we have 3n square plus 601n minus 600n minus 120200 equals 0. So from these two you take n common, so you have 3n plus 601 minus, from these two you take 200 common, so you get 3n plus 601 equals 0. So you have n minus 200 into 3n plus 601 equals 0. Equate each of them to 0, so you get n equals 200, or n equals, here it is minus 601 by 3. So n cannot be a negative number, so therefore n is equal to 200. So the number of terms is 200. So observe all the four options. It is option B. So let's move on with the second one. The common difference of an arithmetic progression is 5. Then what is A18 minus A13? So let's see, what is A18 minus A13? So we know that AN is equal to A plus n minus 1 into D. Right? So what is A18? A18 is nothing but A plus 18 minus 1, which is 17D, minus A13 is A plus 13 minus 1, which is 12D. So you have A plus 17D minus A minus 12D, and this is equal to A gets cancelled. So you have 5D. So A18 minus A13 is 5D. So here the common difference of an arithmetic progression So here this is the common difference. So D is 5. So therefore this is 5 into 5, which is 25. So check out the 4 options. This is option C. The answer corresponds to option C. Very easy problem. Third one. What is the common difference of 4 terms in arithmetic progression such that the ratio of the product of the first, fourth term to that of the second and the third term is 2:3, and the sum of all the 4 terms is 20. So whenever such problems are given, we have to consider the terms in such a way that the common terms get cancelled out. So instead of considering the 4 terms as a plus d, a plus 2d and a plus 3d, what I would do is, let me consider the third term as a plus x, a minus x, and then the fourth term is a plus 3x, and here a minus 3x. So the common difference is 2x here. So when I add all these 4 terms, the term x gets cancelled and you are left with a. So it helps us to find the value of a very easily. Now given the sum of all these 4 terms, now if I add the 4 terms, a minus 3x plus a minus x plus a plus x plus a plus 3x, it's been given that it is equal to 20. So x gets cancelled, so 4a equals 20, and what is a? A is equal to 5. Right? So representing the terms in this way will help us to find the value of a very easily. Next, what has been given? The ratio of the product of the first and the fourth term. So the first and the fourth term. So if I take the product, I have a minus 3x into a plus 3x, and then I have the product of the second and the third term, a minus x into a plus x. So observe that this is the form a minus b and a plus b. So you get a square minus 3x the whole square. So this is 9x square. And this would be a square minus x square. Right? So here this is the product of the first and the fourth term. And this is the product of the second and the third term. So first into fourth term divided by second into the third term is nothing but equal to 2 by 3. So you have 3 into first into fourth term equals 2 into second into third term. So this is second into third term. So this is 2 and this would be 3. So 3 into first into fourth term is equal to 2 into second into third term. I hope it's clear. So here if I expand, you would get 3a square minus 27x square equals 2a square minus 2x square. So I bring this to the other side. So you get 3a square minus 2a square gives me a square. This becomes plus 27x square. So you get 27 minus 2 is 25x square. Now we already know the value of a, which is 5. Right? So a square will be 25. So a square is 25 equals 25x square. So 25 gets cancelled. What is x? X is plus or minus 1. So now let me take x as the positive value. So therefore, what is the common difference? The common difference is 2x. So observe the common difference is 2x here. So therefore 2x is equal to 2. We need to find the common difference. We don't have to find the terms. So therefore the common difference is 2 here. So observe all the 4 options. The answer is D, which is 2. So the common difference D is 2x, which is equal to 2, which corresponds to option D. Fourth one, there are 60 terms in an arithmetic progression, of which the first term is 8 and the last term is 185. So the first term is 8, so A equals 8, and the last term AN equals 185. So we need to find the 31st term, given that there are 60 terms in an AP. So therefore this is A60. So A60 is 185. So A60 is A plus 60 minus 1, which is 59 into D. So what do we have to find? We have to find the 31st term. All right, okay, so 185 equals A is 8 plus 59D, or take 8 to this side, you get 177 equals 59D, or what is D? 177 by 59, which gives me 3. All right, so now I need to find A31. What is A31? It is A plus 30D, 30 into 3. So this gives me 98. So this is A31. This corresponds to option D. So question 5 is a tricky one. The first and the last term of an AP are A and L. So the first term is A, the last term is L. If S is the sum of all the terms and the common difference is L square minus A square divided by K minus L plus A, then K is equal to. So now we need to find the value of A, and this is nothing but the common difference T. So we know that if the first and the last term is given, the sum to n terms is nothing but n by 2 into A plus L. Right? So we have to remember this. Also, what is the last term? L. L is equal to A plus n minus 1 into D. So we have to remember these two expressions. So from this, we have 2S. Right? So the sum to n terms is S. So it's given as S. So 2S is equal to n into A plus L. And also what is L? L is equal to this expression. And also given D is equal to L square minus A square divided by K minus L plus A. Now from this, we find that L minus A divided by n minus 1 equals D, isn't it? So D is L minus A divided by n minus 1. So now, if you observe the common difference here, the expression given in the question, you do not have n. Now what is n from this expression? N is 2S divided by A plus L. So let me substitute the value of n here. So you have D equals L minus A divided by, instead of n, I will write 2S divided by A plus L minus 1. So this is L minus A divided by, I take LCM, 2S minus A plus L. Here in the denominator, I have A plus L. I take it to the numerator, I get A plus L. So here L minus A into L plus A is nothing but L square minus A square divided by 2S minus A plus L. Now compare these two expressions. When I compare these two, I have K here, I have 2S here. So what is K? K is equal to 2S. So observe the options. The right option is option B. So therefore K is equal to 2S. A very interesting and a tricky problem. The sum of 11 terms whose middle term is 30 is. So you have 11 terms. The middle term is 30. So if I have 11 terms, A1 to A5, A6, A7 to A11. So I have 5 terms here, 5 terms here. The middle term is A6, which is 30. So we need to find the sum of all the 11 terms. So what is S11? N by 2. 11 by 2 into 2A plus 11 minus 1, which is 10 into T. Now what is A6? A6 equals A plus 5D, which is equal to 30. Alright, so now from this expression I have 11 by 2. Let me take 2 common here. I have 2 into A plus 5D. So 2 gets cancelled. Now what is A plus 5D? It is 30. I substitute A plus 5D equal to 30. So therefore S11 equals 11 into 30. So when I do 11 into 30, I get 330. So what is the right answer? If you observe all the options, it is option B. So this corresponds to option B. Another simple problem. Next one, 7th one. There are 4 arithmetic means between 2 and minus 18. Now what are they? So you have minus 18 and 2. So you have 2 and then you have 4 more. So let me call this as x2, x3, x4 and x5, and x6 is minus 18. Right? So in total you have 6 terms. So the common difference is D here. It is D, D, D and D. So how do I get the sixth term? I get the sixth term by adding 2 plus D plus D plus D plus D plus D. So minus 18 equals 2 plus 5 into D, right? 5 Ds, right? So what is D? So I get 5D equals minus 20, D equals minus 4. A very simple problem. So now I need to find all the values. So I have 2 plus D, which is minus 4. So the next term is minus 2. Minus 2 minus 4 is minus 6. Then you have minus 10, minus 14 and minus 18. So these are the 4 middle terms. So observe all the 4 options. Minus 2, minus 6, minus 10, minus 14 corresponds to option D. So D happens to be the right answer. Eighth one, if the nth term of an AP AN is 5n minus 3, then we need to find the sum of the first 10 terms. Alright, so now what is A1? The first term is put n equal to 1. 5 minus 3 equals 2. Find the 10th term. A10 equals 5 into 10, which is 50 minus 3, which is 47. And we know that S10 equals n by 2, which is 10 by 2, which is 5, into A plus L. The first term plus the 10th term. 2 plus 47. So 2 plus 47 is 49 into 5 gives me 245. So the right option is option B. Problem 9 is a tricky one. Find the sum of the series. So we have 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus so on. And then the last term is 1 plus 2 and so on up to 20. So this itself is an arithmetic progression. So in the first one you have one term, 2 terms, 3 terms and then 20 terms. So we need to find the sum. Now if I have a series of numbers, say 1 plus 2 plus 3 and so on, how do I find the sum? We know that the sum is n by 2 into 2a plus n minus 1 into d. Now in general n is n here because I want to find out the expression, the general expression for the sum of numbers which are in arithmetic progression where the common difference is 1. A is 1. So 1 into 2 plus n minus 1, and what is d? D is 1 here, right? So it's going to be n by 2 into 2 plus n minus 1. So this is going to be n into n plus 1 by 2. So given any sequence of numbers, say I have 1 plus 2 plus 3 and so on, a set of numbers, then the sum up to n terms is given by the expression n into n plus 1 by 2. Now we have to apply this expression for all these terms. Now what is the sum? The sum is, for the first term it is 1, for the second term it is 3, and for the third term, so here n is 3 here, there are 3 terms. So it's going to be 3 into 4 by 2. So that will give me 3 into 2, which is 6. So remember 3 plus 2 plus 1 is 6. So like this, I need to find the sum individually for all the 20 terms. So here this is the sum up to the first term, the second term, then the third term, and then fourth term. So it's going to be 4 into 5 by 2. So that's going to be 2 into 5, which is 10. So you get 10 here. And then S5. So that's going to be 5 into 6 by 2. So that's going to be 15 plus S6. So what is S6? 6 into 7 by 2, which is going to be 3 into 7, which is 21, plus S7. 7 into 8 by 2. So that's going to be 7 into 4, which is 28, plus S8 is going to be 8 into 9 by 2, which is going to be 9 into 4, which is 36, plus S9 is 9 into 10 by 2. So that's going to be 9 into 5 is 45. Plus S10. Now what is S10? 10 into 11 by 2. So that's going to be 5 into 11, which is 55. So here I've calculated up to S10. But here you have numbers given up to 20, isn't it? So I need to calculate similarly S11, 12, 13, 14 up to S20. So make sure that you do the calculation. I'll write the sum of those numbers directly. So S11 I've already calculated. So we have up to 55. S11 is 66. Then you have 78, 91, 105, 120 plus 136 plus 153 plus 171 plus 190 plus what is S20? S20 is 20 into 21 by 2. So it is 10 into 21, which is 210. Right? So this is S11, S12 and so on up to S20. So now add up all these numbers. So when I add up all of them, I get the final sum as 1540. So this is a pretty lengthy problem. It's not a difficult problem, but it is pretty lengthy. It will take a lot of time. So the total sum would be 1540, and you check all the options, it would correspond to option B. So this is the 9th one. 10th one, in an arithmetic progression with a positive fraction and every alternate term is an integer. If the sum of the first 11 terms is 33, then the fourth term is. So given the sum of 11 terms is 33. So we know that S11 is equal to n by 2, which is 11 by 2 into 2a plus n minus 1, that is 11 minus 1, which is 10d. Alright, so this is 33. So we have 33 equals 11 into, so if I divide both of them by 2, I get a plus 5d. So again 11 3s are, so a plus 5d equals 3. Now given that the arithmetic progression starts with a positive fraction and every alternate term is an integer. So it starts with a positive fraction and every alternate term is an integer. So we know that a plus 5d equals 3, right? So therefore it is starting with a positive fraction. So let the first fraction be 1 by 2, the second one is 1, and then you have 3 by 2, because every alternate term is an integer and it starts with a positive fraction. So therefore if the alternate terms are integers, then the difference has to be, the common difference has to be 1 by 2. So the next one would be 5 by 2, and then you have 3 and so on. So this is a1, a2, a3, a4, a5, a6. So the fourth term happens to be 2. So a4 happens to be 2. So the right option is option A. Next, 11th one. 5 distinct positive integers are an arithmetic progression with a positive common difference. If their sum is 1, 0, 0, 2, 0, find the smallest possible value of the last term. Now there are 5 integers. So since you have 5 integers which are in arithmetic progression, let me consider the 5 numbers as a plus d, a plus 2d, a minus d and a minus 2d. So this is done so that when I add all of them, what happens? D gets eliminated, right? So here the common difference is d. So we know that the sum of all these 5, so a minus 2d plus a minus d plus a plus d plus a plus 2d, the sum of all these 5 is 1, 0, 0, 2, 0. So when I do this addition, all the d values get cancelled, they get eliminated. So we have 5a equals 1, 0, 0, 2, 0, or a equals 1, 0, 0, 2, 0 by 5. So I get the value of a as 2004. Now what happens if I consider the 5 values, the 5 numbers as a plus d, a plus 2d and so on? What happens when I add them? you will have A as well as D. So a convenient way is to consider the arithmetic progressions in this format, so that when I add all of them, the value of D gets cancelled. So A is 2004, and then we need to find, now what is the smallest possible last term? So here 2004 is the middle term, the third term. The smallest possible value of the last term will be such only when I have the common difference is equal to 1. So if D is equal to 1, then the fifth term, A5, will be 2006. Right? So this is the smallest possible value of the last term, which is going to be 2006, and this corresponds to option C. 12th one, in an AP, A is 3.5, D is 0, and N is 101. And then what is AN? What is the last term? So if the common difference is 0, then the last term will definitely be equal to the first term itself, because the common difference is 0. So we don't have to calculate. So therefore, the answer is B. This is a very easy problem. The number of common terms to the two sequences is, so we have two sequences 17, 21, 25 up to 417, and then you have 16, 21, 26 up to 466. All right, so here in the first sequence, what is the common difference? The common difference D is 4. So let me call this as D1. And here, what is the common difference? The common difference is 5. So let me call this as D2, which is 5. Now I need to find the number of terms which are in common. How many terms of these two arithmetic progressions would be common? So I find that the first term is 21. So for the first sequence, the common difference D1 is 4. So the next term will be 25, and then 29. Then you have 33, 37, 41, 45, and so on. For the second term, D2, the common difference is 5. So let me list it out. 26, 31, and then you have 36, 41, 46, and so on. Now what is common between these two? Now the last term of the first sequence is 417, and here this is going to be 466. So the first term which is common to both the arithmetic progressions is 21. The second term will be 41, and the next term will be 61, and so on. So I find that the common difference of this is 20. Right? So I need to find the value which is common to both the sequences, and I need to find the number of terms in the new arithmetic progression. So for this arithmetic progression, A is 21, D is 20, and I need to find the value of N, and AN, the final term, has to be less than 417. So it has to be less than or equal to. So we have the expression A plus N minus 1 into D must be less than or equal to 417. So 21 plus 20N minus 20 must be less than or equal to 417. So you have 20N plus 1 less than or equal to 417. So take 1 to this side. So it is 20N must be less than or equal to 416. So N must be less than or equal to, you get 20.8. So therefore N is equal to 20. Right? Because N has to be an integer. So therefore the value of N is 20, and this corresponds to option B. 14th one, the sum of first two n terms of the arithmetic progression 258 is equal to the sum of first n terms of the arithmetic progression 57, 59, 61, so on. So what has been given? So here, if I find the sum of two n terms, now for example, let us assume that n is 10. So if I take the sum of 20 terms of this arithmetic progression, And then if I take the sum of 10 terms of this arithmetic progression, they would be equal. So therefore, let me consider the first arithmetic progression. For the first arithmetic progression, A is 2, D is 5 minus 2, which is 3, right? And n is of course equal to 2n. So the number of terms here is 2n. So Sn is equal to, that is the sum to n terms is equal to n by 2. So here it is 2n by 2 into 2a, 2 into 2 plus 2n minus 1 into 3. And this is equal to the sum of the first 10 terms. So here the first term is 57, common difference is 2, and the number of terms is n. So the sum would be n by 2 into 2 into a, 2 into 57 plus n minus 1 into d. So 2 gets cancelled, n gets cancelled. So you get 4 plus 6n minus 3 here. And this is equal to, here I would get, so here I would get 4 plus 6n minus 3. And here I would get 114 plus 2n minus 2. So you have 6n plus 1 into 2. So this 2 gets multiplied here, equals 114 minus 2 is 112 plus 2n. So we have 12n plus 2 equals 112 plus 2n, or 10n equals 110. So 0, 0 gets cancelled. So n equals 11. So the number of terms of n is equal to 11, and this corresponds to option C. Let TR be the rth term for an AP, where R equals 1, 2, 3 and so on, right? So now there are two positive integers m and n, where Tm equals 1 by n and Tn equals 1 by n. So we need to find the value of Tmn. Now what is Tm? We know that the general expression for the last term, the mth term, is a plus m minus 1 into d, and that is equal to 1 by n given. Similarly, Tn equals a plus n minus 1 into d, and this is equal to 1 by m. Alright, so now let us subtract these two. If I subtract these two, what do I get? Subtract. So a gets cancelled. So we get md minus d minus nd plus d equals 1 by n minus 1 by m. So again dd gets cancelled. And among these two, d is common. So I can take d common. I get m minus n equals, if I take LCM here, I get mn, m minus n. So m minus n gets cancelled. So what is d? D is 1 by m into n. So here I have Tmn equals a plus, instead of n I have mn, m into n minus 1 into d. Alright. Now I have a plus mn, so I need to get one of these expressions here. So let me add plus n minus 1 into d. So when I add plus n minus n, the value of the expression does not change. So this would be a plus mnd plus nd minus nd minus d. So let me group a, nd and minus d. So I have a plus, from these two I'll take d common, so I get n minus 1 into d plus mnd, and then you have minus nd. This is Tmn. Now observe that what is a plus n minus 1 into d? It is Tn. So Tmn is, so this entire term is nothing but Tn. So this is going to be Tn plus, now this is mnd minus nd, so I can take nd common outside, or I can just take d common, so I have mn minus n into d. Now what is Tn? Tn is 1 by m. So this is going to be 1 by m plus mn minus n into d is 1 by m into n. That is what we have got here. So you have 1 by m plus, let me remove the brackets, I have mn by mn minus n divided by m into n, right? So this becomes 1, n gets cancelled. So I get 1 by m plus 1 minus 1 by m plus 1 by m minus 1 by m gets cancelled. So this is equal to 1. So Tmn is nothing but equal to 1. A very tricky problem. The answer is C. So 16th one. In an arithmetic progression, d is minus 4, n is 7, an equals 4. Then what is a equal to? So we know that an equals a plus n minus 1 into d. A very straightforward problem. An is 4 and what is a? A is unknown, plus n is 7. 7 minus 1 is 6 into d is minus 4. Right? So you have minus 24, which goes to the other side, becomes plus 24. So a is 24 plus 4, which is 28. So the value of a is 28 and the option is D. A very simple problem. Again, 17th one is a tricky one. If 4 numbers of an arithmetic progression, so 4 numbers of arithmetic progression are such that their sum is 50. So the sum is 50 and the greatest number is 4 times the least. So the greatest number is 4 times the least number. Alright. So whenever the sum of the numbers is given, so we have to take the numbers in such a way that d gets eliminated. So here, since I have even number of terms, so let the arithmetic progression terms be a plus d, a plus 3d, a minus d and a minus 3d. So what is the common difference? The common difference is 2d here. So now when these 4 terms are added, so when I add these 4 terms, I have a minus 3d plus a minus d plus a plus d plus a plus 3d. This is equal to 50. So all the d terms get eliminated. So we have 4a equals 50, or a equals 50 by 4, which is 25 by 2. So I've got the value of a. So remember, a is not the first term here. Alright, the first term is a minus 3d. Now what is being given? The greatest number, that is the largest number, is 4 times the least number. The largest number is a plus 3d and this is 4 times the least number. So 4 into a minus 3d. I can equate both of them. Then substitute the value of a here. So you have 25 by 2 plus 3d equals 4 into 25 by 2 minus 3d. So 25 by 2 plus 3d equals, so 50 minus 12d. So remove the brackets. So 2 2s are 2 into 25 is 20, 4 3s are 12, so you get minus 12d. So bring minus 12 to this side, so you get 15d equals 50 minus 25 by. So this would give me 15d equals, if I take the LCM, 100 minus 25 by 2, so that would give me 75 by 2. So 15d equals 75 by 2. So 15 5s are, so you get d equals 5 by 2. So we have calculated the value of d, which is 5 by 2. We also know the value of a, which is 25 by 2. And we need to find the numbers. So what are the numbers? The numbers are a minus 3d. A is 25. So a minus 3d is 25 by 2 minus 3 into d. So 3 into 5 is 15 by 2. So that is 10 by 2, which is 5. Next, a minus d, which is 25 by 2 minus 5 by 2, which is 20 by 2, which is 10. A plus d. So if we calculate 2, then we'll be able to find out the other two, because the common difference is 5 here. So a plus d is 15 and a plus 3d is 20. So the numbers are 5, 10, 15 and 20, and this corresponds to the option A. So the numbers are 5, 10, 15, 20, and this corresponds to option A. 18th one, the first 4 terms of an arithmetic progression whose first term is minus 2. So the first term is minus 2, which is A, and the common difference is minus 2. So what are the 4 terms? Very easy. So you have the first term is minus 2, the second term is minus 2, which is minus 4, the third term is minus 4, minus 2, which is minus 6, and then you have minus 8, and this corresponds to option C. A very easy problem. Next, 19th one, the first, second and the last term of an arithmetic progression are A, B and C respectively. We need to find the sum. See, this is the first term, this is the second term, and this is the last term. So this is an. Now what is the common difference? The second term minus first term. B minus A is the common difference, and an is C here. Alright, so what is an? An is equal to A plus n minus 1 into D. So you have an, which is C, equals A plus n minus 1 into D is nothing but B minus A. So from this, let me find n minus 1. So you have C minus A divided by B minus A equals n minus 1. Or what is n? N equals C minus A divided by B minus A plus 1, because I need to find the value of n. N is not known, right? So this would be C minus A plus B minus A divided by B minus A. So the value of n is C plus B minus 2A divided by B minus A. So this is n. Now what is the sum to n terms? It is n by 2 into the first term plus the last term, A plus L or A plus an. We know the value of n, so you have C plus B minus 2A divided by B minus A. The first term is A, whereas the last term is C. So you have A plus C. So this is sum to n terms. So observe that the sum to n terms is B plus C minus 2A into A plus C divided by B minus A into 2. So you have 2. It is n by 2, isn't it? So you have 2 and 2. And observe that this corresponds to the option C. Right? So this corresponds to the option C. Again, though the problem looks very tricky and difficult, it's actually a very simple problem. We just need to find the value of n, substitute the value of n in the sum expression, and you'll get the answer. 20th one, the 21st term of an AP whose first 2 terms are minus 3 and 4 are. So A is minus 3. This is the second term. What is D? D is the second term minus the first term. So 4 minus of minus 3, which is 7. So I need to find A21 is A plus n minus 1. 20 minus 1 is 21 minus 1 is 20 into D, which is 7. So you have minus 3 plus 140, which is 137. So the answer is option B. A very easy problem.